Hello once again, ladies and gentlemen, and welcome to the final episode of Computercraft with Jtank4. I'm sorry it's been so long since I recorded the last episode. I've gotten a brand new computer and a brand new video card, so you'll notice there's a lot less lag, if any at all, for that matter. So, as for what's going on in this episode, I'll be chased by a horde of zombies. These zombies will be helping me demonstrate a new defense system that I put into my house. If I run in here, I have a hidden computer underneath the staircase. Boot that up. Yes, I would like to activate the defenses. And hopefully these zombies will cooperate and come over here so that they can be killed by my defense system. Come along, zombies. Come along. So you'll see there is fire coming out of there, and there are potions of instant healing. And potions of instant healing, since potions have inverse effects on mobs as they do on people, they actually hurt the zombies. So the combination of fire and those potions quickly take care of the zombies. So now I'll be cutting over to the back of the house, where I'll demonstrate to you some of the code and redstone concepts that I used in making this defense system. See you soon. Hello again, and welcome to the backyard, where I will be showing you some of the redstone concepts and code that I used in the making of the defense system that you just saw in the front of the house. The first thing I'd like to show you is a little trick involving glowstone, where if you stack glowstone in a manner like this, and then put redstone on top of it, the redstone current will actually travel from here into this block, into the redstone above it, and onward, upward. The 15 block limit on how far redstone signal travels still applies while going upward, but you can always just renew it with a repeater. This is definitely the best way to carry redstone current upward without any kind of mod, obviously. This may be staying or it may be going. It's a feature that's currently in 1.5, but as far as I know, it's still in 1.3. Could be going in the future, though. The next thing I'd like to show you is a little simple setup that uses a pressure plate to transfer a redstone signal into this wooden block and into redstone dust below it, where it's carried out of that block with this torch, which inverts the signal, carries it into this inverter, and then feeds into this dispenser full of arrows. So when we step on this pressure plate, it successfully fires the arrow. You can see this redstone turns on, this turns off, and then that redstone torch turns on, and it fires an arrow. The next thing I'd like to show you is a bit more complicated. It's kind of a conglomeration of two devices, really. It is the wonder that is the T flip-flop switch. So, what the T flip-flop switch does is actually a fairly simple thing. All it does is allow a single pulse, say something you'd get from a button, to permanently turn something off, and then permanently turn something back on. There's basically two main parts to a T flip-flop switch. Keep in mind this design is my own, and there are far better ways of doing it. Some of them narrow it down to maybe less than a 3x2 space, which is really amazing compared to my monstrosity here. But it gets the job done. That's what's important for this video. The way it functions is it has two main parts. The first part is this iron block here. It doesn't have to actually be an iron block. As long as it's a solid block, it will take current from a redstone torch below it and transfer it into a wire beside it. This wire goes into the thing that you're powering, and it also goes into the second part of the machine, a inverter, which feeds into this piston, and this piston's purpose is to block redstone current to this engine. Right now, since this is on, this piston is back because it's inverted, and this piston will be able to push the iron block into that position when I push this button. However, now that it's in the off state, this iron block is no longer pushing this over here, and this is actually out and blocking current to this piston. So when I push the button again, only this piston will be able to move the block back in place. So works perfectly. So that's the T flip-flop switch. Fairly simple when you really get down to it. And now it comes to the fun part, the code. So, the code. The code is fairly simple. This is not the exact code that I used in the computer in the front of the house, but it is fairly similar and contains all the main elements. So this is a program that I wrote, and it basically prompts you what speed you'd like to fire arrows at. Let's enter right in the middle, 2.5, and then you hit enter, and it'll start firing the arrows. Now the way that it fires these arrows is actually important. It uses the same way that this pressure plate uses to transfer redstone into the block below it, inverts it, carries it up here, and then this is the way that you have to carry currents into blocks above. You can't simply put redstone below and then a block on above. If this redstone was powered, this block wouldn't be. You have to do it like this, where a wire or a repeater feeds a current into the block which has a torch on it, and then above the torch is the block that you want to power. Obviously, if you want it to act normally, you'll have to have this current inverted. But onto the actual code. Here's how it works. Alright, so the code. Here's what it does. It clears the screen. It asks you what speed you'd like to fire the arrows at. It then reads your answer and puts it in a variable called speed. It checks whether you've actually entered a speed greater than 1 and less than 5. And then it makes a new variable called t. T is what I use to control how many arrows it fires. It's used in a loop statement. While t is less than 15, it'll do these things over and over again. It'll set the output, the redstone output of the bottom to true. It'll sleep for the speed times 0.3 seconds. So that's where the speed comes in. That's why 1 is actually the greatest speed and 5 is the slowest. Then it will set it back to false and sleep for that amount of time again, and then it'll add 1 to t. So that's why it fires 15 arrows. Then it'll end the statement once it's looped 15 times. It will print target eliminated, have a nice day, and then it will end the program. However, if you had entered a variable less than 1 or greater than 5, it would just say this, very well, canceling, and then it would end the program. That's all the code. Fairly straightforward, fairly simple, and very effective. So, the final episode of Computercraft has finally come to an end. We need to discuss what I'm going to do next. I could do a completely new series called Mathematics with Jtank4, where I would discuss everything from Algebra 2 to Pre-Calculus. There is some fairly advanced stuff in Pre-Calculus, and I think it would definitely benefit some people if I did a series on it. However, there is another option. I could begin studying some more advanced features of Computercraft and teach them to you. Some of these might include GUIs, or graphical user interfaces. There are a couple of programming options that were included in Computercraft for these. You can fairly easily make some lists and display different things on the lists depending on variables. So I could begin learning about that and then start the series and teach you about it in hopefully a good explaining manner. I think I'm fairly good at explaining things. I don't know if you agree. But please voice your opinions on this in the comment section. And of course you could ask me to do both series. I wouldn't mind. I'd probably do it if enough people asked. So, Those are your options. Please consider them and voice your opinion. And as always, be sure to have a great day.